All right. Hello, everyone. I'm Professor Caudill. Today we're on 60, 67. We'll start at E. Let me zoom in here. All right. So we are doing I cross E. So we know I, that's just a unit vector. So B is going to be 5 cosine 53, 5 sine 53. It's going to give us 3 and 4. So we're going to rewrite this as 3, 4, 0 because apparently cross product needs to be 3 dimensions. So how are we going to do this? So we're going to take 1, 0, 0 cross 3, 4, 0. We're going to take the bottom line, put it on top, and do it again. Now we can cross, and it'll keep the components I, J, K in the right order. So it's going to be 0, I plus 3 minus this plus 0, J. So we're going to have 4 plus 4 minus that 4 K hat. So now we're going to verify on a calculator. Okay, so we get 4. Cross product is 4. All right. And for F, now we can do J cross B. So 0, 1, 0. 0, 1, 0 cross 3, 4, 0. So 0, J plus 0, I'm sorry, 0, I. 0, I plus 0, J. Three K. Okay. So we got -3. So I know what that means. But I don't like that that's that that spells trouble for my method. No, wait, I know what happened. So I just rewrote this wrong. It should be 0 times 4 minus 3 times 1. So no, my method's fine. I just messed minus sign. Okay. Three I minus J cross B. Okay. So 300 minus 010 equals 3 -1 cross. I'm hoping I can just do it like that. I think I can. So 340. So 0 0 -4 -1 4. So equals 0 I 0 J. So we have 12 minus -3. So I'm getting 15K. $15K. All right, and let me make sure I can I add I and J unit vectors? Okay. Better safe than sorry. All right, now we're going to do B hat cross B. So B hat is B divided by square root of B cross B, B hat. So we know B hat is 340. So that's 9 plus 16, 25. So B hat is 1/5. Three-fifths, four-fifths. So 9 plus 16, 25. Okay. Just double checking. 3/5, 4/5. It's giving us a very small number. So we're going to take this. We're going to cross it. All right, so what do we do here? Do we trust our intuition? Because that's going to be a pain to calculate. Okay, maybe we can... Maybe we can kind of estimate it. Okay, so let's round this up. Let's say it's 110 cross 340. So we're gonna get 0, I checks out, 0, J. So we're going to get 4 minus 3, 1. 1K just double checking. I'm just making sure I'm not making a silly error anywhere. The magnitude is B cross B, which is 25. Square root of 25 is 5. 3/5, 4/5. So well, I mean, the calculator hasn't been wrong. So I'm just gonna say we are right. I know this is a very gross approximation, so I'm not too worried. It's just like 10 to the negative 16. That's really, really small. So where we were on 67. Okay, so this is just more cross products. So we have a 2, -4, 1. C is 3, 4, 10. So we're going to cross these. So we have -40 minus 4. 3 minus 20. We have 8 minus 12. This should be a J plus 20K. -44, -17, 20. All right. Okay, now we are going to do 3, 4, 10, cross 2, -4, 1, 10, 1, 4, -4. So we're going to get 4 minus 40i 20 minus 3j -12 minus 8. Okay. So -36i Okay, so did we get the right answer? So I'm just gonna swap these. D, D, and we get, maybe I can't do that. Okay, so 4, this should have been 4 minus 40. So really this should be 44. So this is why we calculate, because it catches arithmetic errors as well. So if that's right, then the rest is right. Okay. Last one. -24k. So I'm tired of scrolling, so I want to scroll less. So we're gonna take this. So let's see, what are we doing? We're doing -3, -4, 0, -3, 4, 0. We get -24. Okay, I lied. We have one more. -2, 3, 2, cross negative 9j, so that's going to be 0, negative 9, 0, 2, 3, 0, negative 9. So we're going to get 0 minus 18, so 18i, 0 minus 0. So now we're going to have 18 minus 0. So 18k. And we get 18, 18, 18. Sweet. So I guess since I'm doing cross products, I can just move this to the top as well. That would also make it less scrolling. Do I even need, I don't even need to display these anymore. Okay. All right. All right, so we're doing A cross F dot D. So that's saying 10 cosine 30, 10 sine 30 cross F is 20 cosine to 10 and E is 20 cosine 143 . Okay. We got a couple things to calculate. Ten cosine 30. So 9, 5. Cross. Let me give myself some more room. 9, 5. Cross. 20 to 10. Negative 17, negative 10. Dot. Dot. So this final answer is going to be a number. We want 20, 143. So this is negative 16, 12. Okay, so before I calculate, we're going to convert these to 3 dimensions so we can take a cross product. So 0i plus 0j, we get negative 90 minus 5 times 17, negative 17. So it's going to be a negative number. It's just going to be plus. So 90, so 5 times 17, what's 5 times 20? 5 times 10 is 50, 5 times 20, it's 100, minus 15, it's 85, so negative 5k, that's what I'm guessing. So let's go ahead and calculate it, 5. So we got negative 5. So 0, 0, negative 5 dot negative 16, 12, 0. So that's going to be 0 plus 0 plus 0 plus 0. So I guess I'll go ahead and add three-dimensional dot product. So that's C and D, where C is 0, 0, negative 5, dot negative 16. So the number should just be 0, which means they're parallel. Okay. 0. If dot product is 0, it means their vectors are perpendicular. Okay. So these vectors are perpendicular. I guess we could visualize it. We have negative 5. Okay. Then we have negative 16, 12. So from this angle, it looks like it's 45, but really this is a 90-degree angle because we're looking at it from a three-dimensional. So if I could tilt this, you can even see that when the perspective changes, the 45 changes to a 90-degree. So you can see it appears like a 45, but it's really a 90-degree angle. So since there's no z dimension, Well, there is maybe. Okay, this actually is a Z. Okay, forget everything I just said. So we have 5Z, negative 5Z. So let's go down, negative 5. So we have a vector that's just straight down. And then we had that same vector over here. So it's saying that is perpendicular. That looks more intuitive. Okay, so let's move on. A cross F. So we know A cross F, right? So A cross F is 0, 0, 5. Okay, and we want to take the dot product B cross B. Have we done this? Have we done D cross B yet? B sine 53. Okay, so B is 3, 4. I'm sorry. So okay, so it's D 20 cosine 143. I feel like I've done this. Yes, D over here, 16, 12, 0. Okay, so that's our final equation. So we're going to get 0, 0, negative 5, dot 0, 0, 4 times negative 16. So that is 4 times negative 10 is negative 40, negative 64, minus 12 times 3 is 36. So we are going to get a number 5 times okay. So first let's verify this cross product here. Negative 16, 12, 0, 3, 4. So CD is 100. Okay, that makes sense. So 100 times negative 5 is 500. 500. So we're going to take 0, 0, 5, 0, 0, 100, negative 100. Cross seed should be 500. And there we go. Okay, now we want to do a dot f. So we're doing 9, 5, 9, 5 dot negative 17, 10. D cross B. So that cross D. No, it's just times. Negative 16, 12, 0. B. B is 3, 4, 0. So we are going to get a vector that is 0, 0, 16. We already calculated this. That's negative 64 minus 36, negative 100. So we've already done that, haven't we? Yes. Okay. So 100 times this number, so that is 90. So this is negative 90 plus negative 63 plus negative 50. So negative 203. So we are going to get, let's say this is about negative 200. So we're going to get a vector that's 0, 0. It's going to be a positive number because these are being multiplied. 200 times 100, so that is basically saying 2 times 10 to the 2, 1 times 10 to the 2. So does that get us 3 times 10 to the 4, question mark. So let's start computing. Let's verify this cross product. We've already done that actually. We know that's a negative 100. So really we're taking negative 100 dot. Okay, so I guess we should just do 9, 5, negative 17, 10. Let's verify a 9, a dot b. Let's verify that's negative 203. Okay, it is negative 203. So now you're doing okay, so we got 2.03 times 10 to the 4, or 20300. So when we did this algebra here, when you're multiplying powers, you can add them. So 2 plus 2 is 4. Here, we should have just kept these. So 2 times 2, 2 times 1 is 2. So we should have just kept the 2. All right. $70. If this crosses this. So I think these are arbitrary vectors. Okay, well, let's try a simple case. Is I cross J the same as K if this is equal to, okay, yeah, I guess we could do this. We're testing a specific scenario, so I'm testing A, so I cross J if these are equal. Okay, but I don't think they're equal. So maybe this isn't a good example. All right, let's see what the language model has to say. If A, B, C, D are A, B, C. Guess I can just keep the language the book's using. A, F, B, F. A cross F, F cross B. A cross F, B cross. Got it. I worded it wrong. A F B F. A F B F. Okay, this is the example I was going to use, but I wasn't really sure. AF. Okay, so yeah, I could have kind of gee-whizzed it here, but I had some self-doubt. Um, A, B could differ. Yeah, okay. So no, we can't conclude it. Okay, language model saying no here. So this one for sure, I think. So the F can be moved. I'm assuming this is a magnitude. So if you're moving the magnitude, you can move it to the left. It's just a number. So divide both sides by F. That's 1. So definitely C is definitely yes. So no, no, yes for 70. All right. '71. I think these are the harder problems. So we fly 32 kilometers in a straight line in still air. Fly 32 kilometers in a straight line. Okay, so south of west. South, west, south. So 35 degrees. Okay, so this part A is just saying find components. B, find the distance you would have to fly first. What is B asking? Find the distances you would have to fly first. Yeah, so I'm struggling with this English here. Find the distances you would have to fly in the direction 45 degrees. So what's the distance if you went this way and then think that's what it's asking. Find the distances you have to fly first in the direction 45 degrees. Okay. So we're gonna see if direction. Okay. Okay, so it's saying, okay, I think I'm seeing it. So it's saying find how it would be if you went in a triangle direction. So it wants you to find these. Okay. So I think we can do this. So let's say our basic vector A is going to be 32 cosine. So it's 180 plus 35. So that's 215. So -26, -19. So what are we trying to find here? 45 degrees southwest. So maybe we should write this as C. So if C is 35, okay. So -20. So -26, 19. So another way of writing Pythagoras theorem is C dot C magnitude squared So another way of writing Pythagoras theorem is okay, so what do we know? We know the angle, so we know A cosine 45, A cosine, A sine 45, so that's going to be dot itself. So this is very speculative math here. And then B is so that actually this should be 180 plus 45, 225. So these should be 225. And then this would be 45 degrees northwest. 45 degrees northwest. 180 minus 45 is 135. Okay. Let's say this is just one. So we have A negative A 7/10 0.7 A negative 0.7 A dot itself. Zero 0.98 A. It's A squared R squared, okay. 0.98 times, okay. So let's do the same with B. $135. So let's find the -26, -19. Okay. So C.C is 1037. So 1037 equals 0.98a squared. And here we have 0.7. .7 times r negative. Okay. We're out of time, so I'm trying to finish this up. .98 r squared. Okay. Plus 0.98 b squared. So we divide this by, so 137 divided by 0.98. Okay. So 1079 equals a squared plus b squared. 1079 minus a squared equals b squared. B equals and then so this is my attempt at calculating that. I think I'm totally off, but it was a fun play. We'll call this just playing. If you go back in the book, go back to the picture actually. So it's we found this vector, that vector, and we're trying to find the components of this. So it's kind of like a reverse Pythagoras theorem. Maybe we'll try everyone next time. We'll see. All right. Thank you guys for watching.